You've learned about the Pythagorean Theorem in classes before, back in middle school, or at some point I'm sure that you've heard the Pythagorean Theorem, this idea that with a right triangle here, which is a triangle with a right angle, the sum of the squares of the legs being the shorter sides, of the right triangle equals the square of the hypotenuse. In other words, a squared plus b squared equals c squared. Now we're not going to go through some of the more fundamental examples of this. If the Pythagorean Theorem is new to you, then I would encourage you to go watch the video underneath this one on the Blackboard site, underneath the additional videos page. There's some good review examples of how the Pythagorean Theorem works. We're going to use a couple examples here. One using numbers, kind of some fancy numbers that you might not have seen before in a previous class, and then one that actually produces an equation. So the first example that we'll look at, and I'll just use my triangle here, is where this side is 5, this side is 5 times the square root of 3, and this side is x. Now this right here is known as a simplified radical expression. A simplified radical expression because, and you'll see this a little bit later in class, or you might have seen it already by this point, depending on the order your teacher's going in, but radical expressions, usually when we say like the square root of 150, for example, the square root of 150 is the number that when you square it gives you 150. The point here is that I can break down 150 into perfect squares and simplify that radical expression. For example, in this case, I could write that as a square root of 25 times what? 25 times what? 6. Now, the square root of 25 is 5. So the square root of 150 can be rewritten as 5 root 6. But this isn't really the point of this video. This is something you'll be learning about a lot in class. Suffice it to say, we have these two sides and I'm looking for that third side. My formula again is that a squared plus b squared equals c squared. And so what I have here is that 5 squared, that side, plus 5 radical 3 squared equals x squared. We don't know what x is, but that's what we're going to find out. 5 squared, as you well know, is 25. Now, how we square this is a little bit tricky. We break it apart. We square each part individually. Because what we're seeing here is that it's 5 root 3 times 5 root 3. So I can do the 5 times 5, and that's 25. But the square root of 3 times the square root of 3. Remember again what the square root means. And you can certainly type this into your calculator, by the way, and you can get an answer that way, and that's not wrong at all. But it's useful for you to be able to come up with this in your head. The square root of 3 is the number that when we square it, gives you 3. Just like the square root of 25 is 5. 5 squared equals 25. The point here is that when we multiply root 3 times root 3, we get 3 equals x squared. So now that 25 plus 75 equals x squared. That gives me 100 equals x squared. Now we can solve this like a regular quadratic equation. Get everything to one side. 0 equals x squared minus 100. And then that's the difference of squares. X plus 1, 10, and x minus 10 equals 0. And that gives me possible solutions of x equals negative 10 and x equals positive 10. But of course we have to look out for extraneous solutions. X, the length of that side, can't actually equal negative 10. It doesn't make sense for us to think of it as being equal to negative 10. So x equals 10 would be my answer. And so my three sides are 5, 5 root 3, and 10. That would be my final answer for that. So we could just, once we get to this step, knowing that we're going to get a negative 10 as an answer, we could, once we get to here, just say, well, then x is equal to the square root of 100, which is equal to 10. But it's important to remember that as far as this equation is concerned, negative 10 is a solution. Negative 10 is a solution to that because when you square negative 10, you do get 100. So it's a perfectly legitimate answer. So that's when we have numbers. Check out the next video for an example with an equation because those can be a little bit more tricky to set up.